Okay, we're on our last example for the first set of class notes, sections 1.1, 1.2, and 1.3. Again, in section 1.3, we're reviewing trig functions at this point. Example 7 on page 11. In part A, we want to, well, in both parts, we want to solve for the angle theta, and theta is somewhere between 0 and 2 pi. Okay, so these are trigonometric equations. We have to learn how to solve these. Most of the time, we need to use some identity. So in part A, we have sine of 2 theta minus the cosine of theta equals 0. So first of all, we need to get everything to have the same argument, just theta, not 2 theta here and theta here. So we know from our studies so far that the sine of 2 theta is the same thing as 2 times the sine of theta times the cosine of theta. That comes from our double angle identity where we have alpha and beta both equal to theta. So 2 sine of theta minus cosine of theta equals 0. Now we have a simple equation where we can do some factoring, and we see that there's a cosine of theta in each term. We factor out a cosine of theta, and we have cosine of theta times 2 sine theta minus 1 equals 0. So whenever we have a multiplication of two things equal to 0, either one or both have to be 0 for that to happen. So that means that cosine of theta is equal to 0, or sine of theta, 2 sine of theta minus 1 equals 0, which is the same thing as sine of theta equals 1/2. So we know that the cosine of theta is 0 at either pi or 2 pi, and the sine of theta is equal to 1/2. That's from our familiar 30, 60, 90 right triangle. So we know that sine of theta is positive both in the first and the second quadrants. So we would be looking at the angles pi over 6 and 5 pi over 6. Just draw your 30, 60 reference triangles in sine of theta equal to 1/2 in quadrants 1 and 2. And you can see that it's pi over 6, which is 30 degrees, and 5 pi over 6, which is 150 degrees, as measured from the positive x-axis. Okay, and part B, the example, we have sine squared of theta equals cosine squared of theta. The best way to do this is to use our Pythagorean identity. Cosine squared theta plus sine squared theta equals 1, which means that we want to turn one of these sine squareds or cosine squared into the other one, sine squared and cosine squared. So we're going to use the fact that cosine squared theta is equal to 1 minus sine squared theta. So now we have an equation of sine squared theta equals 1 minus sine squared theta. Add sine squared theta to both sides. We have 2 sine squared theta equals 1. And then divide by 2, we have sine squared theta equals 1/2. So to get sine of theta, I need to take the square root. So sine of theta then would be equal to plus or minus the square root of 1/2, or 1 over the square root of 2. So this is also familiar from our 45, 45, 90 right triangle that we really should have memorized. So we can see that the values of theta that are positive and negative, the one's going to be in each halfway through each quadrant. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4.